Hey, this is OXTF, and today we're looking at another challenge from the HackTheBoo CTF. It's a beginner-focused CTF, Halloween-themed, and this is the Day 2 Pwn category, entity. So I get both a Docker instance to spawn as well as some downloadable files. I'm going to start with the downloadable files this time, so we'll take a look at what we got here. And in this case, there's a binary, file entity. Oops, yep, there we go. It's a 64-bit ELF. We could reverse it, but we also have entity.c, which we'll look at. We have a flag.txt, but it's going to be a dummy flag that we here for testing. The real one will have a real one. And so really the place we want to start here is going over to VSCode and taking a look at entity.c. We will scroll up to the top here, and we're going to spend a minute, because this is actually really important, going through the different data structures defined here. So first of all, there's a data structure called data store that is defined to be a union of either a long named integer or a array of 8 characters called string. And what a union means is that means I can access, if I create an instance of this, I can access it by .integer and it will treat the data as an integer, or by .string and it will return the data as a string. And so I can interface with the same memory, treating it as 2 different types. Then I have a couple of enums here. Enums are just ways of sort of defining possibilities, or like menus. So I have an enum called action T that can either be a flag, store set, or store get. I have another enum called field T that can either be an integer or a string. And that's it. Like those terms now become items that I can refer to. And then finally I have a struct here called menu T, which takes an action T, which is an action T named act, so one of these, and then an instance of a field T called field. And so we have a menu T. Let's jump down here to the bottom. Actually, we're going to start with main. And what main does is it creates a data store. It zeroes out. It has this data store thing which it zeroes out. It prints something strange, and then we enter a while true loop. And we start off with the menu where we get a result. We'll come back to that. And we remember from the top here, result is going to be a struct that includes both an action and a field. Okay. So somehow our menu is going to generate that. Then we're going to switch on the action. And if it is, now we have this enum. So it's either one of these 3 things. It can only be. So if it's a store set, we're going to call set field on the field. If it's store get, we're going to call get field on the get field. And if it's flag, we're going to call get flag. So I guess we'll start. Well, before we go to the menu, let's take a look at these 3 things. So get flag says if data store.integer is equal to leet, then I get the flag. Seems simple enough. Get field says, basically, I give it the field, and it says if it's an integer, it prints it as an integer, and if it's a string, it prints it as a string. Set field takes the field again, and so it says, oh, maybe you want, there's a 32-byte buffer here, which it then reads into 32 bytes. I get to put something in, and if it's an integer, it is going to read the integer from this buffer that I just read. It's going to parse it as an integer. This is what long unsigned int. Unfortunately, if I try to put in leet, it's going to say, what is this nonsense, and exit. Otherwise, but anything else, it would set into data store integer. Case string is going to just do a mem copy of whatever I put in into the string version as a string. So raw data. Or raw characters, I guess. So the challenge is then, how am I going to put something in that I need to get the value of data store integer to be leet. Let's go over here and take a look at the menu real quick. It pretty simply says, do I want to run or cry? Try to turn it off, run or cry. If I pick T, it means I'm going to go to set my action to set. If I pick R, get, and if I pick C, flag. And then down here, it's going to set based on, again, lie down or scream. I can pick integer or string. And again, and if I try to pick anything else, it's just going to fail. So how are we going to do this? The trick is going to be that when we say we want to do a set, and let's see if we can find that. When we call set, if we call set on an integer, we're not going to be allowed, oops, let's go up a little bit here. We're not going to be allowed to set it to leet. But if we call set on it as a string, we're going to be able to set the data however we want. And so what's good about that is we can set it to leet as a string. We just need to figure out how to format our data to look like that. So effectively what that means is, I guess we can go over here and interact with it. If I come here and I do netcat, let me go grab my IP import here, and we'll get rid of the colon and connect, so I can, effectively try to turn it off. Does not seem to work. Let's pick by down, maybe a ritual, and put 1337. So that seemed to work. We set it as a, I already forgot which one's which here. Let's see if we can make these exist at the same time. So what we did was we picked, for this one, T was, we set it, and then we set it as an integer, and we set it at, so now if we do a get it, let's see, R, so if we do run, and let's try it again as an L, we're gonna get back our leet. If we do run, and we do it as a S, we get back 9. Now why does that come back as 9? Because this gets written into, let's see, let's pull up here, we can do Python. If I write the integer 1337, let's see, what is that in hex 1337? Does that work? 0539. So the bytes that get written into memory here are going to be OX00, OX00, OX05, OX, oops, /X05. See if I can make this actually look right. OX39. In fact, that would be if it was big endian, but it's actually not going to be that way. It's going to be more, so that's not really a thing, but in memory, it's actually going to sit here and look like OX39, OX05, OX00, OX00. And so when I try to print this as a string, the value 39, sorry, we can keep doing syntax errors. This is not really Python, obviously. If we do char on OX39, that's the value 9. If we do char on the value OX5, it's not actually a printable value, so it just kind of shows up as nothing, and same thing with the nulls. Trying to think of if we have a number we could put in here to, let's see, if we took OX, let's see, if we wanted to do 39, what's the best way to do this? We'll call int on 39, 38, 37, 36, 35, 34, 33, 32, like this, comma, 16. If we put that in as an integer, let's see. So we are going to try to turn it off for T, and then we're going to lie down for integer, and then we're going to paste this in, and it's going to work. Now we're going to try to run to print it, lie down S for scream, and we get, well, because I made some typos, you can see here, because it's in reverse order, there's the 39 is this 9, 38, 38 is 8, 8, 36, 35 is 6, 5, 34, 33, 32, that's that. And where am I getting, how do I get 39 equals 9? That's the ASCII value. The value of hex 39 is the character, ASCII character 9. So if we wanted to instead, we could do something simple like 41, 41, 41 times 8. And if we put this one in, let's see, so we try to turn it off, we set it as an integer, we paste in that integer. Now what we're going to get is all 41. What is 41 when you treat it as a character? It's going to be the capital A. Let's see if that works. With an S, and we get A's. We get 8 A's. So what we've shown here is that we can write the data either way. What we need to do is figure out what's the string we can put in, because we can write any string we want that comes back as leet, or as leet. So we want the string OX37, OX13, OX. Oh no, sorry. We want 1337 as hex. That is the string we want to put in. The challenge is we can't type that into the terminal because these are not characters. So what we're gonna have to do is start writing a script to do this for us. So we'll say vim pwn.py. We will user bin env python 3. We will from PwnTools import star, and that's going to be convenient for us just as we go to start interacting with it. It gives us all sorts of interactive tools. We will say r equals, let's come up here and do import sys so that we can pass this into the command line. R equals, let's see, first thing we'll need is an IP address, not enough. An IP equals sys.arg v1, port equals sys int of sys.arg v2. So now we've got our second argument. And so now we can say r equals remote of IP comma port. And if we do r dot interactive like that, we can now python pwn.py and give it our IP import. See if I can get that back from my off-screen challenge interface. So we give it like this, and remote is not defined. That should come with PwnTools, should it not? Did I make a typo? From pwn import star. pip3 install PwnTools. Well, that's bizarre. Did I import it correctly? Let's try this. Python import pwn. Oh, I make this mistake all the time. This is good. I'm going to leave this in here because, so when I try to import, it's importing pwn.py from the current directory before it gets PwnTools. So I need to move pwn.py to flag.py. Now, if I do vim flag.py, what was happening before is it was importing itself, and itself didn't have a thing called remote. So now if we come here and do flag.py, and we're now interacting with this. You can see we've connected to it. We're now having the same thing. We've got our thing. So let's see, what do we need here? We can probably make this a lot smaller. So now we need to do r.read until, and the first thing we need is this prompt. So we'll say, and they're going to come through as bytes. This, read until that, and we'll do r.send line, and we're going to send t because we want to write, and then we'll do r.read until. We're going to need a b there as well, like this to get our prompt, and we'll do r.send line b, and this time we're going to send let's look up here and make sure we get it right. We've been sending L to get it as an integer, but we want to actually get, this time we want to do it as a string. So we'll send S. And now we'll do r.read until, well, let's see, we can actually just, let's try this real quick to make sure it's all working and I haven't made any stupid mistakes. And see, so it actually worked. Now it's saying maybe try a ritual. So we can come up here and say r.read until this. We need our b for bytes. And now we'll do r.send line. And what we want to send is the number 1337, and we want to convert that to a 64-byte set of data buffer. So we're going to use the P64 thing from PwnTools, and that's going to format it for us, turn it around, convert it to hex, etc. Now, if we've done that, effectively, we should be able to just run the flag. So now we can do r.read until b like this, and then we can do r.send line b, and what was the thing for flag? So c for cry. Very Halloween themed. And then let's see. let's just go interactive at that point and get what's left. So we can say Control C that, and we'll run connect again, and we get a flag. So hopefully this is a kind of a cool way to, first of all, one of the things I really appreciate here, is PwnTools is really useful for, if I can zoom in on it, for interacting with services over a port. To do this with like the socket library would be a huge pain in the butt. And so having these like read until and send line functions are super nice. The p64 function, which is going to take my integer and convert it into a buffer the way I want it to, is really nice as well. In fact, one thing we can show, let's see, why don't I, let's see, Python from pwn import star 1337 1337. So what does p64 1337 look like? And if you remember earlier, that's exactly, this is the buffer. This is a 64-bit 8-byte buffer right here, and it's converted it to little endian the way it would be in this is what it would look like in memory. So this is the same as when we said converted this to hex. You can see our C907CC, and then it's flipping the endianness and setting us up a buffer for us, all in one little p64. So that's super handy. And you'll use that when you start doing more complicated buffer overflows and things like that as well. And then r.interactive actually just lets us play with it, although we don't need to play with it anymore at that point. But hypothetically, I guess, we could, well, if we generated a shell, for example, we could do our r.interactive, or we could, if we don't, just to show it here, we could do this here. And now we've already set the memory correctly. So what if we put in cry by ourselves, and here comes the flag, and then it cuts off. So interactive just says, oh, now you can pick up and start interacting with this. So hopefully this was useful. Thanks for sticking around, and I'll talk to you next time.